All right, starting here we have a work problem. This work problem is that we have a 20 kilogram block sliding along the floor. It starts out at 12 meters per second and the floor has a coefficient of friction of 0.15. We want to know how much work is done by the floor on the block in order to bring it to a halt. Now we know that work is equal to force dot distance, don't want cross product, which is equal to force times distance times cosine of the angle between them. Okay? Well, let's examine that. We know the distance is going to be to the right. We also know what about the force of friction. It's going to oppose motion. So the force of friction is this way. Okay? And of course we also have the normal force and the force of gravity on our block. But really, since the normal force and the force of gravity cancel each other out, we really want the force of friction. Okay, so to do that we need to calculate these three things. Alright? Theta should be pretty easy. It's going to be 180 degrees. Again, because distance is to the right, force of friction is to the left. Next, look at the force of friction. Okay, it's equal to the normal force times the coefficient of friction. We know the normal force is just going to be equivalent to the force of gravity, because in this case they're the only two vertical forces. Alright? So we have times gravity times uk equals 9.8 times 20 times 0.15, and that gives us 29.4 newtons. Alright, now we have to find the distance. This can be the trickier part. Alright, for the distance, we need to know how far it's going to slide, and what information do we have to find that? It's really just a kinematics problem after all. So we want to find change in x. We know V initial equals 12. We know V final equals 0. What other information do we have? We don't have time. We don't have acceleration. Now again, we need to have three of those things in order to solve for the distance. So we need to find time or acceleration. The only information we have is we have this force here. And since the frictional force is the only force causing the acceleration, we can actually find the acceleration from that by knowing that F equals ma. And our a is going to come out to be 1.47 meters per second squared. So by plugging that in, we now have enough information to find our our change in x. Okay, and to do that we're going to use v final squared equals v initial squared plus 2a change in x. Okay? We know 0 equals 12 squared plus 2 times 9, oopsie, not 9.8, times 1.47 times delta x. We get 144 is equal to negative 2 times 1.47 times delta x. Now you can see here I made a slight mistake. I left out a negative sign for our acceleration. Why does our acceleration have to be negative? The answer is that it doesn't. But one of acceleration or distance has to be negative. In this case, I normally take the right to be positive and the left to be negative. Okay, so I'm going to stick with that, and again, we know our acceleration is to the left, so we should make all those accelerations negative. Okay? Alright, so we get that, we get our negative sign, we get change in x is equal to, I'm going to rewrite this so it's not quite as heinous looking. We get change in x is equal to 49 meters. Now, we've got our change in x, which is our distance. We've got our force, 29.4. We have our cosine theta. So, we want to find work. We get work equals 29.4 times 49 times cosine theta. And that's going to give us negative 1440.6. Right, and that is the work done on the object by the floor. Okay, in the bit you'll see, as we move on, you'll see that this makes sense that it's negative because the block lost energy. All right, there you go.